is the NEET 2018 question basing on motion in one dimension, and little carefully it has to be solved. Let's have a look at the problem. A toy car with a charge Q moves on a frictionless horizontal plane surface under the influence of uniform electric field. So the first thing that he is saying is there is no gravity effect and there is no frictional force effect. The only force acting is force due to the electric field EQ, that is equal to ma. So it's under a constant acceleration of EQ by m. How much is that? How much is that? E is not necessary in this problem, right? Yeah. Due to this force Q, velocity increases from 0 to 6 meters per second in 1 second duration. Let us consider that part of the problem. It is saying we have started from the rest. In 1 second, velocity became 6 meter per second. So let us stop here for a while and see what happened in this 1 second, right? I can say after 1 second, I can use a formula V equal to U plus AT. V is given as 6, U is 0, A I don't know, but after 1 second. That implies during this journey it has an acceleration of 6 meter per second square. Might have also covered some displacement and distance. I want you to calculate them because I want in the problem what is an average velocity, that's what, and average speed. So calculating distance or displacement is also relevant. I can use a formula S equal to ut plus half at square. U is 0, a we find as 6, and t square is 1, that is 6 by 2, 3 meters. So what happened after 1 second is it has covered a displacement of 3 meters. It has an acceleration of 6 meter per second square. That's that part of the problem. Let's have a next part of the problem. At that instant, the direction of the field is reversed. So what happens when the field is reversed is the acceleration starts acting in a negative way. Field is reversed, so the force is reversed, so electric field is also reversed. So that is minus 6 meter per second. And it continues to move for 2 more seconds. It is before coming to the rest under the field, it has moved for 2 more seconds. So before going to 2 more seconds, first of all, we need to know whether it actually able to move without coming to the rest before that 2 more seconds, right? Let us consider 1 more second that I am talking about. 1 more second. So what I am talking about is actually second. This is the first second, this is second second. So after 2 seconds, what happens? Let me find out. After 2 seconds, V equal to U plus AT. What is this V I want to calculate? U is starting from here, 6. A is minus 6 and T equal to 1. That is 0 meter per second. That is in second. So by the time it reaches, it has covered the second, its velocity becomes 0. That's why, though it is given that for 3 seconds it will continue to move, for 2 more seconds it continues to move, I cannot take all 2 seconds together. Rather, I have to take only second into consideration because by the time the second is completed, its velocity is becoming 0. So velocity is becoming 0. So in second also it covers some displacement. I can say S2. How much is that? I can use the formula ut plus half at square. U is 6 in the second, T is 1. A is minus 6 because it is reversed. T square is also 1. Be careful, I am not writing for entire 2 seconds, but I am writing only for the second because after 2 seconds, its velocity became 0. I call that as V dash. Yeah, what happens now? 6 minus 6 by 2, that is 6 minus 3, that is 3 meters. So in second, it has covered another distance of 2 meters. Now the velocity became 0, still there is a force acting in reverse, in opposite way. The force is acting in reverse because electric field is reversed. Now it can't move forward further, rather in third second, I'll draw here, it starts moving in backward direction. This is the third second. That is from 2 to 3. That's This is 1 to 2 seconds. Sorry, 0 to 1 second. This is 1 to 2 second. This is 2 to 3 second. Velocity already became 0. For one more second, that is third second, it moves, right? So as it moves, even for the third second, I can find the displacement in third second. In third second is equal to again ut plus half at square. S is 0 into t is 1, half a is minus 6 into t square is 1 square, that is minus 3 second, which tells you that in first second it moves 3 meters forward. In second second, it moves 3 meters forward. But in third second, it moves 3 meters backward. Be careful about it. So, it has covered a distance of 3 meters in backward. Once you got that, then what is an average velocity and average speed between 0 to 3 seconds? Finding out that is quite easy. How can I find out? Tell me. Average velocity is total displacement by total time. Total displacement is in the first case 3 meters, in the second case 3 meters. But be careful in the third case, that is minus 3 meters by total time 3 seconds. That is 3 by 3, that is equal to 1 meter per second. That's the average velocity. So these two options are definitely ruled out because average velocities are given different. And you can also find out average speed as total distance by total time. Total distance means in the first second 3 meters, in the second second 3 meters. The third second also I will write plus 3 meters because when you are talking about distance, you don't take about science into consideration. Only magnitude is important. By 3. That's 9 by 3. That is 3 meter per second. So this is the answer. 1 meter per second average velocity, 3 meter per second average speed. So while you are solving this problem, we are depending on very basics. You shall remember them carefully. And only thing, very important thing that you need to understand is, though it continues to move for 2 more seconds, it is not going to have a linear motion in the same direction for the 2 more seconds. For the first second, it moves forward. For the second second, it moves forward. But for the third second, it moves backward. That's an important thing that you need to observe because by the end of the second second, its velocity is already 0 and still there is a force acting in the opposite way because of that reason. So it's a important problem that you need to understand. You need to know the basics of this topic well to solve this problem. Relook into the problem if necessary and make a comment if there is any kind of doubts on that. That's it for now. Thank you for watching.